Okay, chapter 7.4, the other trigonometric functions. We are on page 6 of the notes. Page 6 goes back to what you did in college algebra or algebra 2. We want to make sure that you remember how to translate or move functions from that standard position from the parent function. So A, y equals x squared plus 1. Okay, that's a parabola that has been moved up 1. So I'm going to start by picking numbers here. I can plug in 0, 0 squared is 0, plus 1 is 1. 1 squared is 1, plus 1 is 2. If I plug in 2, I get 2 squared is 4, plus 1 is 5. And now I'm going to go the other direction. I know what a parabola looks like. I've got a vertex, and then it should turn around. -1. -1 squared is 1, plus 1 is 2. And when I plug in -2, I get -2 squared is 4, plus 1 is 5. So when I go to graph this, I got 0, 1, 1, 2, -1, 2, 2, 5. Pretty standard parabola that has been moved up 1. Sketch that in here. If you remember your vocabulary with parabolas, we've got an axis of symmetry. The axis of symmetry cuts it in half. Happens to be the y-axis here. I know this is reflected across the y-axis, which makes this an even function. So my reason for saying this is an even function, it's reflected across the y-axis. Or we can look at values. F of 1 is 2, which is the exact same as f of -1. F of 2 is 5, which is the exact same as f of -2. That makes this function even. You got to be careful. Sometimes you can pick that one number that's going to be the same for the positive and the negative, but it's got to be the same for any x we choose. Okay. Y equals x to the third. This is the standard cubic function. So again, my anchor point here is going to be 0. If I plug in 0 for x, I get 0 for y. And then I'm just going to go 2 values on each side. So when I plug in positive 1, 1 to the third is 1. So when x is 1, y is 1. When I plug in positive 2, 2 times 2 is 4, times 2 more is 8. I get y equals 8. When I plug in -1, -1 times -1 gives me a positive 1 times -1 again. I get -1 for y. And then when I plug in -2 for x, I get -2 times -2, which is positive 4, times -2 again, I get -8. So here I get positive 1, 1, 2, 8, -1, -1, -2, -8. And so here is our pretty standard cubic function. This function we know is odd. That somehow got cut off here. So we're going to write it in. Reason, f of 1 gives me positive 1. F of -1 gives me -1. So when I plug in the opposite value, the opposite input, I get the opposite output. This is also symmetric about the origin. Last example here, I've got y equals x minus 2, quantity squared. So again, this is a parabola. This time we're shifted 2 to the right. So I'm going to see what happens when I plug in x equals 2. I get 2 minus 2, that's 0. 0 squared is 0. So when x is 2, y is 0. This is a parabola, so I'm just going to pick 2 numbers to the right, 2 numbers to the left, and just plug and chug, crank out some numbers. 3 minus 2 is 1. 1 squared is 1. 4 minus 2 is 2. 2 squared is 4. And we're going to go the other direction. 1 minus 2 is negative 1. Negative 1 squared is 1. 0 minus 2 is negative 2. Negative 2 squared is still positive 4. So I'm going to go ahead and graph this so I can see what it looks like. I get the parabola that looks pretty much the same as the one up above, except instead of shifting up 1, we've shifted to the right 2. Notice here, our axis of symmetry right down the middle is the line x equals 2, so this does not reflect over that y-axis. And so this, we know, is neither. Okay? F of x does not equal f of negative x. If I plug in 2, I get 0. If I plug in negative 2, I get 16. So this is not even. And I'm going to use my little cheat method, does not contain origin, because this graph does not go through 0, 0. So it's not odd. And that is it.